Hi everyone, welcome to the 21st AWS User Group Edinburgh. Thank you very much for everyone who's joined us tonight. We've had a few people joining late, which is why we've started a few minutes late. I'll introduce you to our main speaker in a second, but just to talk you through the structure of the evening. Thank you. Rough proceedings, as you can see, we're starting slightly late, but the presentation will run for about an hour and a half. I'll introduce you to the speaker in a second, but at the same time, we've got John, the solutions architect team lead from Cirrus, who will be answering any questions as you go. You can ask as they go along, and we'll have a separate Q&A at the end. Hi, John. So if you've got any questions as we go along, please feel free to answer them, and we'll either try and answer them as we go along, or we've got some time saved at the end to have a proper chat through. You can see from the picture there in terms of how to answer a question ask a question if any of you haven't used GoToWebinar before. So to introduce our speaker, who's been sitting here silently otherwise, is Michael Vannon, the tech lead for Cirrus HQ. I will hand you over to him and he can do a bit more of an introduction into who he is and what he's going to talk about tonight.
Thanks, James. And hello, everyone. Good evening and welcome to the user group. Tonight's topic is a really interesting one and one that I'm really passionate about. It's serverless as such, and in specific, AWS serverless computing. Just to give a brief intro, James already said I'm the technical lead at Cirrus HQ. I'm also 6x AWS certified and TOGAF certified. I do hold both the professional certifications. I'm very much a serverless enthusiast and a DevOps advocate, and my Twitter handle's on screen. Feel free to follow me. Let me start by saying this: servers suck, right? Anytime you want to deploy an app, there's a lot of operational preparations that needs to be done, right? Every time we do this, we have to install the software, we have to configure it, and if the application's in the cloud, we'll have to set up scaling. When we set up scaling, we need to then guess the scaling needs. We need to do scaling policies. Every other guesswork that needs to be done, and performance tests, etc. All the good stuff, right? And not just that, we need to then think about patching the servers. We need to think about patching the application as such. We need to think about maintenance of the maintenance of the system. And not just that, we then need to think about infrastructure monitoring, operational, all the operational alerts that come with that. All of this, and we still haven't actually gone live with the code app. We haven't. So that's one of the reasons why servers suck. And just looping into the next part, which is serverless. What is serverless actually? Does serverless actually mean there's no servers behind the scenes? Actually not. It's an operational construct. What it means is the servers are actually abstracted. You don't need to maintain or manage the server. Someone else does that for you. It is also a way to describe services, practices, and strategies that help you build more agile applications. It then helps you to respond to change much faster. So that your developers and architects can actually focus on writing code that serves your customers or serves your business functions. One of the key aspects here is everybody would have come across terms like infrastructure as service, platforms as service. This is actually functions as a service, right? You're only worrying about writing code for the functions, and you know what? These functions are designed to serve a particular purpose or or a business function. There is a really lovely blog written by one of my colleagues, Pete Jackson. The link's up on screen. When we share the presentation, you can all feel free to go and have a look at that. It gives you very much a high-level introduction of what how to leverage serverless architecture as such. Coming back to this point, in software architecture terms, when you're talking about functions as a service, there always needs to be a trigger, right? A trigger then can come in via any type of form. A trigger can be an event, and what is actually an event? Event can be an RPC, a remote procedure call from a different function. It can even be like a cron task triggering something, right? And it can be an API call as well. So all these terms then feed into something called an event-driven architecture, which we will go through during the later slides. So what are we actually covering today? We've just covered about what is serverless right now, right? So the structure of today's thing is we've covered what is serverless. Then then we talk about why serverless. Why should you be using serverless? Then we talk about how, right? And how do you do serverless? Architecting your applications to be serverless. And then it's live demo time. Yay! If the demo gods kind of favor us today, we will have a very successful demo. It's quite an interesting topic, and I'm hoping you will all love it. Then we just talk about very briefly about the spectrum of AWS serverless or serverless offerings. We will be covering a lot of it while we go through the presentation, but this is like a high level idea of all the other services that can hook up into being, into helping you create and use serverless as such. Then we have a little bit of questions time. You can keep asking questions as we go through the presentation. In any case, John's here and he will be answering stuff, and we will have a little bit of a session at the end to go through some of the interesting questions as well. So just jumping right in, why serverless? Serverless, as such, Amazon actually views serverless as the native architecture of cloud. You don't need to worry about provisioning anything, as we were talking about much earlier in the slide. You don't need to worry about the management tasks. You don't need to worry about installation and configuration, capacity provisioning, patching. Everything's kind of just handled by AWS. Then there is automatic scaling. If you compare automatic scaling with the server-based stuff, we don't actually need to worry about scaling policies and such. Because if you have used auto scaling groups, we all know that you need to set scaling policies based on something. Whereas in serverless world, you don't really care about it. It just does what it does, says on the tin. It scales automatically. And you pay only for what you use, and it's actually built on a highly available and secure architecture just out of the box. It heals itself. We don't need to worry about minimum amount of servers to be in service, etc. Or if you are working in spot instances, you don't need to worry about when the instances are going to get pulled below your feet. Nothing like that, right? So it's great. So how does it actually fit in with your business realization? We were talking about increased agility. It's basically focus on your code and not on operations. It then means an easier and faster go-to-market, right? There is a really lovely case study by Edmunds, who are like a car seller and an information gatherer. And this is something that we come across as a company in multiple other clients and from multiple clients and customers who interact with this. Things that used to take like weeks or months takes literally days to go live in serverless world, and that's what Edmunds has also had experience of. Then we talk about elasticity. We talked about the automatic scaling. That's what elasticity is. And one of the financial engines, which is basically an investment advisors, they kind of went from near zero downtime to near zero performance degradation when looking at a scale, as you can see, 200 to 300 million requests a month, right? That's really big scale in terms of numbers, and it's amazingly cost efficient, right? If you take a look, Lambda and the pricing model, I'll go into a little bit more detail about the pricing model later on in a slide, but they are based on the number of requests and the time of execution for a Lambda, which is very different from a server-based world or even on-premise or data center, where you have a very high initial cost. And when we have like a pricing model of 20 cents per million requests, and you're billed in milliseconds for an execution time, it just becomes so much more cost efficient in such a way. And you can already see a couple of case studies where these people have had that experience and have realized that business value for them. So just slightly diving a little bit more deeper into the pricing model, there is actually a free usage tier where you get like 1 million free requests a month and 400 GB seconds of compute time per month. When we're talking about 400,000 GB seconds, right? When we're talking about in milliseconds billing, and an example is on screen for you guys, which is like if 128 MB function running for 200 milliseconds every time it runs, and 30 million requests cost just over $11 a month. That's even lesser than most of the pizza prices these days, right? So great, Andy Jassy, who is the current slash outgoing CEO of Amazon Web Services, has basically said in one of his talks, if Amazon.com were to be starting today, it would be completely serverless, right? So these points actually kind of loop into how, why you should be doing it, because in a one-line answer to that, business value realization is so much more better when you're doing serverless, and it's so much more efficient, and it's so much more better compared to where servers were, and serverless is the future. That is why. So let's go into the next part of things. How, right? The next question is actually how, and how architecting to be serverless. And what is actually serverless? When we were talking about serverless actually also having servers, right? So this is like a spectrum of services that's spanning across multiple different areas. We go from more operations, which is on-premise, to serverless being cloud native. So you can see most of the times when we're doing cloud migrations, people have systems on-premise, and these systems need to be moved into the cloud. They first do lift and shift, and then from then on they start tweaking and at the end what they want to have is essentially a managed service, or a complete or they start re-architecting their systems to become completely serverless. So if you look at the offerings, right, virtual machines on premise is kind of equivalent to EC2 on the cloud. If you think about it, RDS, MySQL, if you're going on premise, you're running a MySQL VM on premise, then you can easily do a MySQL VM on EC2. Then you go to, which is essentially infrastructure as service. From then point onwards, you go to managed services, where you take the management of the systems away from you. You still are responsible for quite a lot of it under the shared responsibility model, but a lot of it is actually on Amazon to manage, which comes to the managed services. Shared responsibility model is something that's its core functional, it's a core principle of Amazon, where each service have a different shared responsibility model, where we as the users are responsible for something, versus Amazon as the provider is responsible for some more of it, right? And this responsibility is what differentiates serverless from an IaaS or managed services thing. Serverless, in a serverless world, a lot of these things are actually managed by Amazon, while we as users are only very much in control of a very small amount of configuration that needs to be done. For example, in the last slide, we were talking about a 128 MB function, which is basically you're saying my function needs a 128 MB of RAM. That is the level of involvement you need. You just need to say that, okay, my function can run in 128 MB RAM, or my function can run in 256 MB RAM. That's all you need to do. And examples, right? We were talking about MySQL on EC2, then you go to RDS on MySQL, then it becomes Aurora MySQL, then it's actually Aurora Serverless. Similarly with EC2, you can run whatever you need on EC2, then goes Elastic Beanstalk, and then from then point onwards, you do containerizations, or if ECS, and the serverless offering for ECS is actually Fargate, where a lot of it, including scaling, is done by Amazon. And then there's serverless, which is completely functions. And one of the most recent releases is actually you can actually use containers as part of functions in Lambdas as well. And the other, if you look at these layers, like compute layer, the database layer, the storage layer, the messaging layer, analytics layer of any, these are like the most common layers on most of the platforms that we kind of architect, web systems or anything like that, or any solutions architecture has these layers in it. And you can see already the spectrum of things going, and the offerings from going from more operations, which is on-premise, to being completely serverless. And you can see there are services for each one of these layers that is completely serverless. Why is this important? Because when we talk about architecting for serverless, we will most probably end up leveraging all of these functions, or one or more at least of these services. Lambda, Dynamo, S3, wherever required, an SNS or an SQS or step functions. And sometimes if you're involved, if the app has the functionality to do analytics for it, you can use Athena as well as part of it. That's why it's important. So coming into architecting for serverless, one of the core concepts here is microservices, right? Monoliths are world, where you have this big systems which does everything, and there are black boxes all over the place. No one really knows what you need to do. Whereas in this new world, where you start using microservices, it's basically an architectural style, right? It is a suite of small services by decomposing the big monolith application into smaller items, each running its own processes, each communicating with its own lightweight mechanisms. They can communicate between each other, across each other, as you can see in the diagram. They are almost like a piece in a jigsaw. If you break the whole architectural into a jigsaw puzzle and you have little small pieces, microservices are exactly that. And they are quite essential in terms of agility, because you can then, from a development point of view, you can have teams dedicated into developing and maintaining a microservice, right? So that's kind of a very high level idea of what they are. What they are not is they are not defined by a number of codes. Microservices doesn't mean it needs to fit in 50 line of code. It is exactly the opposite. Microservices are supposed to be serving a function, right? So, or solving a problem, or addressing a capability of the system. They are not just CRUD operations, create, read, update, delete operations. They are not just that. They need to solve a particular problem is what they need to do. They are not, they're not like subroutines or anything like that as part of a bigger function. They're not that. So as I was saying, they are a set. They are its own capability solving mechanism. That's what they are. A very kind of high-level examples of what a microservices-based architecture is. As you can see in the screen, on the left-hand side, what you're seeing is like an e-commerce application. So you can see a mobile app is coming through an API gateway. It has various different services like account service, inventory service, shipping service, a web front-end service. These are actually microservices in essence. They solve a particular problem or address a capability of the system, account capability or inventory, stock inventorying things, or shipping things out as well. They can talk to their own DBs in a sense. They don't need to go to this big relational DB. They can talk to their own little DBs as well. So that then decomposes and separates the load that needs to go onto the databases as well, which has traditionally been one of the hardest things to scale properly. So on the right hand side, what you're actually seeing is, if you can guess what it is, Uber's microservice thing. It's a very, very high level microservice architecture for Uber. You have passenger management, a web UI for passengers, a driver management, a payment gateway, a billing, notifications, etc. Right? So, that kind of is a very high level view of Uber's microservice. But then the next part you're going to see is actually Amazon and Netflix's microservice architecture. Amazon lovely, like really actually calls their microservice architecture the Death Star. You can see it, how it reflects the Death Star actually. So these various microservices can interact with each other, and that's how one of the reasons why Amazon and AWS as such are able to release so many features in such a short period of time. If you've been in reInvent, the sheer amount of releases that goes into a reInvent or pre-invent even, and even regular releases, right? And because they follow this kind of an architecture across the Amazon.com, across Amazon Web Services, that's what enables them to be that rapid in their delivery and agility. Netflix, kind of similar, right? So you can already see how complicated things can get in a way as well. Even though it can get complicated, it is actually quite useful to be doing it in a microservices thing, because as I keep repeating, I keep repeating this, it gives you the ability to pick and choose things. And if one thing fails, it doesn't mean everything fails. It means that one small part fails and you can easily go in and fix that small part without taking the whole system down. Whereas in a monolith world, that would definitely have been the case. One part or one RPC or one function fails, literally to take the whole thing down. So just reiterating the same points, right? Helps you focus on infrastructure. It reduces the focus on infrastructure, and it helps you focus more on applications from an infrastructure point of view as well. So you don't need to worry about configuring the services and stuff for it. When you're using Lambdas, and if you're using Lambdas or ECS Fargate for your microservices, you don't need to worry about it, because if you go back to the last slide, the sheer amount of microservices that these big companies use, they wouldn't be that scale if they were still focusing on the infrastructure. So how does a typical small world, in essence, architecture look like? You have an event source. If you remember, I was talking about event-driven architecture, right? So an event is usually required to trigger a function in any sense. For in any software engineering world, people know that if you want to call a function, how do you call a function? Something needs to trigger the call. So here we use an event source. Event source can be anything. It can be changes in data state, a change in the dynamo, a database records get updated can be an event. Request to an endpoint, an API call can be an event. Change to a resource state, for example, shut down an EC2 instance, or boot up another EC2 instance. That can actually be an event as well. It can be anything. A function, the function as service, the core part of serverless. Node, you can write functions in any of these supported languages currently. Node, Python, Java, C#, Go, PowerShell, and Ruby. They are kind of supported in Lambda, in the Lambda world. And what a function can do is up to your imagination. It can be anything. As it keeps, when we're doing microservices, it just needs to solve a function, right? So it can be talking to a particular service behind the scenes in Amazon, or it can actually call to a different function or a third-party application as such as well. To give an example, in AWS world, an event source can be a call into an API gateway. It can be CloudWatch events, if you come across that term before. CloudWatch events are the ones that get triggered every time there is a resource state change. EC2 instance gets started, stopped, terminated. They are CloudWatch events. You create an S3 bucket or upload an object to an S3 bucket, CloudWatch event. They can actually trigger, for example, they can actually trigger a function. Function world, Lambda, ECS, EKS, services, DynamoDB, S3. So I keep referring to Lambdas, right? I keep saying Lambdas, so the functions, they are amazing as serverless functions and stuff. So what actually is a Lambda? Lambda actually lets you run code without needing to provision or manage servers. It can actually run even containers on an EC2 backbone, which has been like a very recent release actually in the last few months, where Amazon's now let you containerize whatever you need to do and actually upload that as a Lambda. It is the true function as a service. So it is very much different from the ECS service, where you are running containers, whereas you're packaging a container and running a container as a function inside a Lambda. To create a function, you need to choose three main things: runtime, size, and permissions. If you think about the shared responsibility model I was talking about in my earlier slides, there is a couple of configurations we do need to do, which is choose the runtime. What does, which language you're running your function in, Python, Node, whatever, right? What is the size you are allocating your Lambda? Can it run in a 128 MB thing, or does it need more memory? The size. And permissions. What services are actually talking to, or what is actually talking to the Lambda, and what the Lambda is talking to. These are the three things we need to configure when we set up a Lambda, and that's all. If you think about when I was talking about why services suck, and the list of things that we needed to configure, install, maintain, manage, it's down to 3 now. So this is why it actually enables you to be so much more faster in going to market or releasing a function, essentially. So DynamoDB, you probably have heard me talk about DynamoDB a couple of times now, which is, it is the data store of serverless. It's what Amazon kind of keeps saying in a sense that it's immensely scalable. You can't, trillions of requests per day, and it can support millions of requests per second. It is a key value and the document database. It is NoSQL. It is a NoSQL database. It's the opposite of relational database services, right? It is this amazing service that's built essentially for serverless applications, right? It has encryption at rest. It is enterprise ready. I said NoSQL. I know there is a lot of people when I talk to even customers and customers and clients and stuff, people go NoSQL. Oh God, NoSQL. That is such a huge domain. I don't want to go NoSQL. I'm coming from a relational background. To be honest, I came from a relational background as well. Every time I kind of think databases, I think a database, a primary key, a foreign keys, and another database hooking up to it, joins, outer joins, and stuff. Whereas thinking it in DynamoDB world, it has been a complete revelation. You don't think about DynamoDB as database, you think about them as tables. And however, is it actually NoSQL though? For encryption people, for these people to address their concerns, what Amazon actually done now is increase SQL compatibility by actually giving a service called PartyQL, which you can actually write SQL queries and run it against DynamoDB. So essentially, you introduce SQL in a NoSQL world. Again, amazing, isn't it? And you can use NoSQL Workbench, which is like a GUI. If people would have used MySQL Workbench to do MySQL relational data modeling, you can actually use NoSQL Workbench to do NoSQL modeling, which is again an amazing advancement in this tech. It wasn't there like 2-3 years ago, I believe. So again, amazing in terms of that. So using NoSQL and these kind of systems and hooking this up with Lambda helps you to build systems of immense scale. Trillions of requests a day, millions of requests per second, right? It usually blows my mind when I talk about that. When we then talk about like what actually goes inside a Lambda function, right? So you have this 3 parts to a Lambda function. The function needs to be called somehow. So it's called the handler. It is like the main function, main part of the Lambda, which then routes to other different smaller subsets at all. The Lambda itself has an event object and a context object, and then you do something inside the Lambda, whatever you need to do. The first 2 lines you're seeing on screen, S3 equal to Bodo, app equal to app, that is like the global section. You can define global items and global variables and values in that place, and then refer to it inside your functions and the Lambda handler and stuff. We will go through all of this while we're doing the demo in any case. Inside an event object is the data that is sent into the Lambda during the function invocation. You remember we talked about anything can be an event that triggers the Lambda. So the anything can actually pass in anything. Fun, right? So looking at in terms of an API gateway and the API call coming into this, and what does an API call usually have? Headers. So if you think about it that way, you're passing in headers into the Lambda, and you can access those headers and do whatever you need to do with it. Similarly, a CloudWatch event comes in. You can have events that pass this resource state change actually into the Lambda itself. So the Lambda can identify, oh, an instance has been terminated. What shall I do? Shall I respin the instance up, or should I tell somebody? A Lambda can do that, right? And the context. So what is event probably needs a context in a way. You need to know what triggered it. So that's what the context object is. So the request ID, it's a unique ID that identifies the request that's coming into the Lambda, which is quite useful when you're looking at debugging and things like that in the CloudWatch logs. You can know which request ID it is, and you can actually trace it through the whole serverless process as such. So we're now coming actually into the demo time. And I was going to kind of run the demo in a scenario-based situation. So this is like a very common use case in a sense, right? We have a data store that has a live stream of Internet of Things sensor entries already available. The data store is the DynamoDB table. So just to give a background of that, let's say, not let's say, I have a Raspberry Pi, right? And the Raspberry Pi has temperature sensor hooked up to it. I have 3. These 3 things are sitting in 3 different rooms, and they keep sending a stream of data back into a DynamoDB table every minute. So it is basically a record of the temperature variances in those 3 particular rooms. These things sit near a heater, just away from a heater. It kind of measures this. It measures the temperature differences that happens in the house, right? This is a little fun project. If you kind of extend upon it, you can see how these things work. An Internet of Things, where you have connected devices all over your house, Alexa, for example, and you're talking to Alexa, behind the scenes, these things can get recorded into a DynamoDB table for some other microservices to hook up to it, get triggered by it, and do something it needs to do. So for this fun little demo, as I like to say, the requirement is I'm going to want to design a new microservice, and this microservice just needs to read the data that is being stored in the Dynamo and get the latest 10 records and display it into our little micro website as such. We are going to build this completely serverless. If you think about the spectrum that I was showing a little bit earlier, a few of the serverless services, we're going to be using them. To host our site, we're going to use S3. So in the proposed solutions architecture, we're having the entry point as the static website page where we're going to display it. The website is going to hook up to an API gateway, doing a GET request to the API gateway, and to get the data out of the DynamoDB table. The API gateway is hooked up to a little Lambda. The Lambda basically then talks to the DynamoDB table, does a query on the DynamoDB table, gets the latest 10 records, and returns it back to the API gateway, back to the website, which then parses the response and displays it in our little demo. So that's what we're going to try and do. As we're talking about, Lambda function is basically the microservice that we're going to use. So I talked about the entry to the end, right? When we are building it, we build it from the reverse. We build it from the Dynamos actually already exists, because as I said, I already have a stream of data going in. For simplicity purposes, I'm kind of keeping the requirements very specific in a way. So the Dynamo already exists. The next part to build then would be the Lambda that reads from the Dynamo. Then we will build the API gateway that will hook up to the Lambda, and then we will build the little website, which will then hook up to the API gateway. And the end, what we hopefully will see is a website that refreshes every minute and shows the changing temperature data on screen. So let's start doing it. Any questions until now? And you can feel free to post the questions, anything that you have into our questions window while I start showing my screen, actually. I'm just logging into my screen, 1 sec. Right, we are inside my AWS account. Hopefully you can see my AWS account. So if you remember, I was saying the first thing, the Lambda, when you're configuring a Lambda, you need to set permissions, first of all, and then you need to set the configuration of the Lambda itself, right? So first of all, let's create a IAM role, which is essentially what will give the Lambda permissions to do what it needs to do. And from the spec, we know what we need, right? We need the Lambda to be able to read and write, just read from the DynamoDB table. And then we will also need the Lambda to be able to write its logs and analytics into CloudWatch logs, which is a service so that you can analyze and check if the service is going okay or not. So first of all, create a role, right? And we're going to create a role for a Lambda. So as simple as that. Then we need to kind of create a policy to which is basically in Amazon world is a JSON document that specifies what a role is allowed to do. I'm not using anything existing, so I'm going to create a new policy. And if you can see that screen, actually, there is 2 ways to do it. If you're amazing coder and you can write JSON on the fly, use that. Or if you're like me, you do this, choose a service, Dynamo. What are all the actions we want in Dynamo? Interesting, right? So do we need list? No, I actually have we probably need to list a list of tables, okay? We need to read the data. We need to be able to scan or query the data. So query or scan. Maybe describe the table as well. We can give that permission, but probably not required, but hey ho. Particle, if you remember, I was talking about particle, right? So particle select is the one that enables you to do SQL queries against Dynamo. We're not going to be doing that, but it's good to know that it is, this is a permission you would need in that aspect. But hey ho, we just need query, scan, describe, and list tables. We're not going to tag or write, so we don't need to specify any of it. We're just going to give all resources for the purposes of this demo. And we also need additional permissions, as I said, to give permissions for CloudWatch logs. So CloudWatch logs, there it is. When you're setting a Lambda up, you need to be able to, the Lambda usually creates its own log file. So you need to be able to give those permissions to it. So we need to do create log group, create log stream, put log events into it. So if we and then we'll give permissions to all resources, that's fine. Create log group, create log stream, put log events is all. I think these are all the permissions that's required. So if we find that we need more permissions, we can always come back to the screen and give it more permissions, right? So next, tags. I usually, it's one of the best practices to usually tag something. So I'm just going to say purpose is AWS UG demo. One thing you probably need to know is it's really best practice and very much recommended to tag everything that you create in Amazon, because if you end up 2 weeks down the line and you forget why you created something, the tags usually help. And it's also useful for other purposes like cost center allocation, things like that in an enterprise world and stuff. So review, I need to give it a policy name. So let's call it AWS User Group Live Demo Dynamo, right? I'm just going to give the same thing as here. CloudWatch, write, DynamoDB list and read, purpose, okay, create policy. So the policy has been created, but we need to attach that policy. So just refresh the set of policies. And there's usually, you can see how many policies AWS managed things are customer managed. So customer in this context is us as users. So these are the things that we created. So we just created this AWS User Group Live Demo Dynamo. So using that one, tags, purpose, is UG User Group, review, need to give up Lambda, just giving it a name, and create role. So we've created the role now. Now we need to start creating a Lambda. Going into Lambda, I'm going to create function. I like to write in Python, so I'm just going to write Python code as such. So let's keep, we talked about what are the basic configurations you need to do. You need to kind of set a name for the function. Let's just give get IoT data. Runtime is, as I said, I'm going to run Python, so Python 3.8. I want to change the role to an existing role, which we just created. So I'm going to say AWS User Group Live Demo Lambda role. advanced settings. We can talk about VPC and stuff, but I'm just gonna leave it in no VPC for this point. Create function, as easy as it gets. Now we just need to write code. So when you create a function, you usually get this file lambda function.py, and you can already see there is a lambda handler with the event and context object in it to do implement. So what I'm going to do is start writing some code. And the code that I'm going to write is actually going to be written in Boto 3 frameworks. I'm just going to replace this in any case. So import JSON, importing the JSON thing. I'm not going to go through writing how to write Python, but I'm just going to hopefully try and give you an idea of certain sections here. So import JSON, import Boto 3. Boto 3 is the framework that Amazon gives, Amazon supports, that hooks up to all the AWS APIs to do and interact with resources in terms of AWS world. And from the Boto 3, I'm kind of importing a certain library called conditions, Boto DynamoDB conditions and import key, import date and time, so that we can get the latest 10 results in. Then I'm going to actually initialize certain global items in it. So first of all, we need to then define what we are going to do, which is initialize the DynamoDB resource as such, saying, okay, Lambda, here you go, create an object called DynamoDB, which will hook up to my AWS accounts, the account that it is running, and by default, it will default to the region it's running. So to be running on the EU West region, so you can see I'm using the Ireland region. And then I'm specifying the table that I'm using, which is the IoT stream data, which is the table that already exists. I'll show you the data. I could potentially just show you that one just now. So DynamoDB table. So you can see there is a table called IoT stream data. Can see indexes, and you can see there is like 1710 items in here. There is a lot of things going on. So this is basically the data store we're going to read data from. Well, so I've said initialize my DynamoDB object with the table IoT stream data. Then I'm going to say I'm going to define a global array, list, essentially an array. These are my device IDs that I've given my devices. So there's like 3 devices, as I said. So I'm just defining them as a global array for it. Then we're going to write a little, then we're going to start writing the Lambda handler as such. If you noticed, I'm actually copying and pasting from a different screen because I'm not going to type and fill up everyone's time. So the Lambda event and context handler has been here. So I'm going to initialize a couple of empty objects so that they can be returned in a way. And if you write Python, you know that tabbing is quite important. And I'm going to say go through each of those device IDs, right? So from this array of things for each device ID, I'm going to try and do a query for it. So while I'm doing a query, I'm going to write a little function that does the query for me. So if you can see here, I'm going to ask a query result is a variable, and I'm saying I'm going to call a function called query latest device data, and I'm going to start writing a little function for it. I like to write little functions rather than a big monolith one big function kind of a thing. So little function here. So I'm going to say I'm going to use a variable to assign the results to, and then I'm going to start doing a little query now. So in the query, I'm kind of saying do a query to the DynamoDB table. This is the key condition expression. Find me the key called device ID, which is equal to the device ID that's being passed into this query, and the timestamp is greater than or equal to from yesterday. If you think about it, I did say the latest 10 results. So I'm giving a limit of 10, and I'm saying scan index forward. This, if you can verify these things inside the Amazon documentation, provide documentation and stuff. But scan index forward, setting it to false, means it will take the most latest thing in a descending order. So if you think about it, if I'm saying anything greater than 10, 30, which is yesterday, and over 10 o'clock from yesterday, and if I'm saying limiting it to 10, and if I'm saying scan index forward false, it will get from now onwards and go back in time, right? So that's how it works. So the reverse, it takes the reverse. It's not from yesterday to now, but from now on till yesterday as a limit. So it will get the latest 10 results from there and display it. So we now then return this result as a response back into this variable. It gets stored into it. So now, if you think about it, I need to then do a little bit of transformation of the query data to be able to be read by our HTML page, which we're going to write in a few minutes. So what I'm doing is doing a little loop, going over the items that's coming back for us as a query result, and basically creating another proper data object and going and returning all devices. Returning, all devices is basically the data object for it. And hey ho, it gets returned to whatever is calling the Lambda. So in our world, we're going to build a little API gateway to do that. So you need to then do a deploy, basically deploying the code, as easy as that. And you need to, and every time I write something, we usually say test it. So when I do test, we need to do a test event. If you remember, I was saying you always need an event to trigger a function. We're basically going to trigger create like an empty event in a way. Call it test, create, that's all. And then you hit test, it loads it. And you can see it's gone through it and it's actually returning a bunch of data back from it. So we know that our Lambda works without any errors. Yay, thanks to the demo gods. So the next step now is to actually go into and start creating the next part of our system, which is the API gateway. API gateway, right? So let's create an API gateway. How difficult is this one going to be? Actually, turns out very simple. There are few types of API gateways you need to be aware of. There is HTTP API and REST API, WebSocket API, and a private REST API. HTTP API is by far the simplest of everything. It just supports Lambda and HTTP backends. When I say HTTP backends, it can support an EC2 HTTP endpoint as its backend, where it proxies requests to. Then there is WebSocket APIs. Very shortly, it's like a TCP connection that can keep open for dashboards, which requires a persistent connection, things going on. Then there's REST APIs, which is just ordinary REST APIs that everybody knows about. And this is the one that by far offers the largest amount of control on. And it's a private REST API. It sits within a VPC. It's not exposed to the world, which is quite useful when we are looking at private applications, which is a hybrid application or something like that, on-premise to the cloud, or which doesn't need to be exposed to the world because of data sensitivity and things like that. For this demo's purpose, we're going to do the easiest and the simplest one, which is the HTTP API. If we can see how easy and quick it is to build. Add integration. We have a Lambda in Ireland region. Get IoT data, which was what we built, which was what we just wrote. Give a name. Get latest IoT data. And next, configure routes. Get IoT data. Get IoT data. I'm just gonna say we just need get method. I don't want any other methods into it, so it's just a get method. So I'm just limiting it to that method. Define a stage, leave it at default, review and create. Yep, done. So we've just got an URL now. So what I usually now do is, as I mentioned, test every step. So we've created this one. So we now just double checking if the API gateway actually works. API is basic, a get is basically can be done using a curl request. I like to do it with Postman in a way. Hopefully if you haven't come across Postman, it is a little GUI that helps you to do curl requests and stuff. I'm just gonna sign into the Postman account, sorry. And I'm gonna share screen of Postman. Postman. If you can see my Postman screen, just doing a little bit basic request, get, right? And if you remember, I got like an URL from there. So post the URL in and slash, we had a path, which was gonna be get IoT data, if I'm correct. So I'm just gonna get that one in and get IoT data and send. Hey, we got the same kind of response back what we got from Lambda, which is coming from Lambda, right? Great, that works. What if, if you remember, I limited it to a get request. What if I do post? Not found, because that method's not supported. You literally, from a you can do deletes and stuff, right? So from a security point of view, it is always good to limit these things to the methods that you want it to be. So goes back to not found. So it's get's the only thing that actually works. Great. So we've tested that one, and coming back into our the screen. So we know API gateway works. So now we need to kind of do our next part of the system is actually the little S3 website that we need to build. If you might have come across this before. This is one of the oldest functionalities in S3. You can actually have a static website running off S3 without any servers behind the scenes, nothing, just S3, a bucket, which is basically an object store, can run a website. How amazing is that, right? So I'm gonna do a little bit of, let's say, get IoT data dot. You can name it anything, but because S3 is a global naming scenario, I'm just gonna give get IoT data.mahalvanan.com and leaving it in Ireland. Because we're gonna do a website here, it requires public access, so I'm gonna leave that one unchecked. I'm gonna, tags, right? Don't forget tagging. Purpose, AWS User. Server-side encryption, it's always good to, by default, enable this. It's something Amazon recommends you as and when, and it's always good to do this. There's no extra cost or anything like that for it. Create bucket. Yeah, I acknowledge. Yeah, I know it is public. Yeah, create bucket. Thank you. So get IoT data, right? Now we need to enable website notifications for here. So static website hosting, edit, enable. As simple as that, post a static website. So you need to give an index document and an error document. First of all, index is, I'm just going to js.html because it's a JavaScript file. So I'm just going to do that in, and I'm just going to give the same thing in, no redirection rules required, save changes. Right? So has it actually enabled it? No, it hasn't, because we still have to give permissions. Because if you remember, everything we set up in an Amazon world, we need to set permissions up for it, right? So in this world, we need to kind of set, say, bucket access policies to be able to look at and read from all the, for the public to be able to read and read whatever object is inside this bucket. So for that aspect, I'm going to give a bucket policy in place. Hit edit, bucket. So public read get object, allow anyone, anywhere, S3 get object. and the bucket name is that. And anything under that bucket name should have external access now. So save changes, right? Objects. We need to now write a little bit of code for JS. So I'm gonna share screen of my little Visual Studio Code where I write code in a way. Code. So yeah, so I have a very basic HTML page, right? So just gonna talk through each section in a way before I kind of show. So HTML page, a head tag which just says IoT stream data. It's just a title for a page, and then I'm using the jQuery library. I know some of you guys might probably scream and surprised, why is this guy still using jQuery? We should be using Node.js. Well, I am a very basic coder, and jQuery is something I'm used to. So I'm writing in jQuery. You can write Node.js, React, anything you need. You need or want to. So some of these actually have an AWS SDK built-in part of it, which makes directly talking to AWS items so much more easier. For this purpose, easiest jQuery, which I know quite a lot. I'm giving a little bit of styling. I'm gonna use tables again. A lot of the front-end people will scream in agony. Why is this guy using still tables? We should be using divs. Well, easiest for me, to be honest. Okay, so this is the interesting part, right? So this is the part where we send send a request to our API gateway, get the response, and actually inject the response as HTML inside our HTML page. And if you can see here, body, I kind of have dummy tables in here. So calling device 1, device 2, device 3. There's nothing in them as of yet. So what I'm going to do is, first of all, I'm just going to show you guys by uploading this into the S3 bucket and loading the web page and basically showing we haven't yet hooked anything up to start with. So going back and showing my S3 management console, I'm just uploading the js.html into the bucket, upload it, go back into this page, refresh. Great, there isn't anything here. We have not hooked up the database, or we're not sending an API gateway request yet. Coming back into my code, so we have this little function called fetch data. As I said, I like writing functions, keeps me organized. And inside the functions, I have an AJAX request, which sends a get request, as you can see, a type of get to a URL. We need to fill the URL out, which we got from the last step when we set the API gateway up. And oh my God, demo gods, please help me. So that is the URL, and we need to give the path as well, because that's quite important. That's the root. That is what actually it gets the data. The root one's not mapped to anything, so we need to get that path into the code here. Save it. So now we will do a get request to this. If you remember, we did a postman request, and that was fine. So usually write error handler as well every time. So if there is an error that shows up, says what the error is, useful in debugging. If it is a successful request coming back in, we are getting, we are emptying. If there is anything in there, we're just emptying it. And for, we know that there is like 3 device IDs that I have. So each device gets a table, and I basically insert the data that's coming in as a response, as a table row in each one of those things. And function again, right? So calling the function when the document is ready, is loaded, and fetch data gets called, and then I do this piece of code to do a live refresh every 30 seconds, and without actually refreshing the page, it will automatically keep the data table loaded with newest data as such. So we've now hooked it up. We now need to upload the same back into the S3 console. So going back to that screen, S3 console, upload the file again, upload, done. So fingers crossed. Hey, it's an error. Demo gods, why have you done this to me? Why do you think that's happening? It's actually CORS, which is quite an important piece here. Because if you look at CORS, we are saying there is no other origins allowed apart from the API gateway's own origin. Configuring it, we need to allow everything. Or we can specifically allow that one specific URL as well, but I'm just gonna, for this one, allow everything and allow just the get method as well. And hit save. So the cross-origin resource sharing. So this is a very important thing in a web systems development sort of way, right? If you're not doing this, there is usually cross-site scripting. If you come across it, it is like a attack people do, hackers do, kind of faking things out. And you need to kind of configure CORS in a correct manner to get things to allow only certain other domains to be able to embed these things into their own kind of systems. As soon as we hit it, there we go. It starts working. And I'll keep this one on here, and you can actually observe in like a minute or so. The first lines usually will get a little bit, will change a bit. So you can see the room temperature is 24, 23. It's oscillating a bit. The device ID, the timestamp for each of it, and they get changed. So you can see the timer is like 18, which is British Standard Time versus UTC. We are 1 hour ahead, so we are at 7:43, whereas the time is actually 6:43 p.m. And just waiting until a minute passes, and you can start seeing the other things coming out, another entry coming out as well. Hey ho, look, 6:43, 20. Okay, hold on. We haven't yet hit 44 again, I suppose. If you remember, it goes on every 30-second cycle. So 30 seconds, and we will have another refresh of it. While we're waiting for it, we've just seen how easy it is to configure an S3 website, which hooks up to a JavaScript file, which has a JavaScript file, which is a client-side rendering thing, which then hooks up to an API gateway, talking to a Lambda, to a DynamoDB table, get the data, and everything comes back in and on screen. There you go. A live refresh just happened. You can see 1844 in the first row. Yay! So all in a matter of 30 to 40 minutes, a little microservice on its own. So this is why this is so amazing. Serverless and serverless architecture, writing microservices, and it adds so much value to any business or any systems and solutions that we're doing. That brings us to the end of our little lovely demo as such. So going back to my little presentation, and just yeah, the building blocks. We've built all of this now, and I did promise I'm just going to talk a little bit about the kind of all the other spectrum of AWS offerings that's serverless, what's managed in serverless and stuff, right? In here, if you look at it, we've already touched AWS Lambda. If you look at the serverless column, we've touched the AWS Lambda. We've actually done a bit of CloudWatch, API Gateway, S3, Dynamo. So what's remaining here? There is Cognito, there's Kinesis, there's step functions. Cognito is a authentication system. We are actually doing a much more in-depth immersion day very soon, in somewhere near end of April. I think probably James will talk a little bit on that. We will be doing we will see how Cognito, we can do microservices with authentication involved in it. Step functions is like an orchestrator, because microservice, as what we built was essentially a service on its own. So what if I want to build a service where I'm looking at, if the temperature breaches 30 degrees, I need my AC switched on, right? What happens then? So you need to have a flow of lambdas, right? So you need to have one lambda triggering the other. So one lambda will be looking at every 30 seconds, looking at what the temperature is. Has the temperature actually breached 30 degrees? If it does, trigger another lambda. And another nice little thing, use cases like I want to upload a photo or an image in a WordPress site, or in any site, and it goes to an S3 bucket. As soon as it hits an S3 bucket, you can have a CloudWatch event which triggers a lambda, which then processes that image, creates multiple different thumbnails, and each thumbnail can then be sitting in different S3 buckets, which then in turn trigger a notification, in essence, like trigger another lambda which sends a notification to a relevant stakeholder saying, oh, someone's uploaded some pictures, whatnot. That can happen. Then you have things like X-Ray and Athena, which is amazing to do deep tracing in a way. I will be very quickly showing you CloudWatch logs in a second, going back to my demo just to kind of loop it back in. We've already seen DynamoDB. SQS is like one of the earliest services Amazon offered, I believe, if not the first, I think. It's a queuing service. You send a lot of messages, and it stores in the queue. You can have consumers coming off this SQS, consuming the messages off SQS, doing whatever they need to do. API Gateway, then SNS. SNS is the notification service that we have that can send notifications, SMS notifications, emails, even HTTP even objects posted to an HTTP endpoint. Kinesis is like a streaming service where you can almost have real-time stream of data going through, and a lambda can then process off it, and things like that can happen as well. Some of the other services you might also need to do, not in a completely serverless architecture, but in a managed serverless hybrid offerings, is things like Elasticsearch, things like Redshift, things like Elastic Cache, things like RDS can also be used. These are like Elastic Cache, obviously, as the name says, is caching service. Elasticsearch is the Amazon's version of Elasticsearch. RDS is obviously the database, the relational database store. So just going back a step and kind of showing you guys the CloudWatch logs and stuff as we are hooking things up. Let me share screen again with the other views. Yeah, if you can see my IoT stream screen again. Oh, look, 1849. You can already see a bunch of other things. We started at 1842, if you remember, going back to now 1849 now. So you can see it is live refreshing on the data that's happening in there. You can and then now going back into my Lambda console, just to look at some of the metrics from CloudWatch. Get IoT data is the function that we built, and you can see code test. Now, code is where we wrote the code. Test usually contains the various different test cases. So we have one saved event, which is the test event. Monitors, where you will see the metrics, logs, and traces. So view logs in CloudWatch, or you can actually see there's CloudWatch metrics. You can see it keeps the number of invocations, how long it's taking. It's taking like what, 160 odd milliseconds right now. So if you go into on 1 hour kind of scale, yeah, the execution times are around like 120 milliseconds on an average, no errors. So success rate 100% there. So these are like the CloudWatch metrics you can see, and at the same time the CloudWatch logs. So anytime an execution happens, that gets logged to this log string. If you remember, we did give permissions, so you can see that it is going on and on. And 1941, this is what we've been doing right now, and you can see these things are happening because I gave a print statement inside. The data is being printed as well. If I don't give a print statement, that's not going to happen. That's not going to be printed out. If you remember, this is where I have like a little print statement in here. I can easily take the print statement out, and it will stop putting it back into the CloudWatch logs. So the next time it triggers, probably in a couple of minutes time, it will start doing it. X-ray and things like that are for deep tracing. We will go through them in detail in hopefully in our next much more in-depth immersion day that Serge is going to be running. James will be touching a bit more on it, but that nicely brings us back to the end of what I wanted to talk to you guys about today. A little bit of an introduction into the world of serverless and how easy, how quickly we can deploy a microservice using it to the world. It's just built a little microservice that everybody can access via that little link. So there you go. I will be giving the code as part of the presentation pack in any case, so you guys can rip it apart, do whatever you need to do. It's just a little bit of a code snippet in a way, and you can do your own whatever you need to do with it. So hey ho. Thanks guys, and I think it's question time. Hey.
Hi all. So we'll just pause for a second for any of you sitting there thinking what questions you want to write. So we'll get the questions in by text if you see the icons I mentioned earlier. So we'll give you a couple of minutes just to ask your questions, and if we get any, we'll run through them from there.
Just to mention, the only one we've had so far was around the recording. So we will be sending out a recording alongside the slide pack and the code for this demo, and so you can go through that.
While we're waiting, John, do you think, is there anything, I know you're a very much an machine learning enthusiast, right? So Lambdas and serverless kind of hooks up quite a lot with those things, right? So do you want to say anything about those two things? How like serverless and these things hook up?
Yeah, I can. So one of the demos we'll be doing in our next session is around using Amazon Recognition. So what that is a machine learning service that Amazon have built to do image classification and recognition and find what types of objects are in different images. And the way the demo will be working is it'll be a very similar process to what Muhal has shown there, but it'll be uploading an image, triggering a Lambda, which will then call recognition, do the machine learning identification on it, and return those results through to the Lambda, and then you can actually get the results of what type of image it is, what is detected in the image, and various things like that. So there is a lot of serverless offerings in the machine learning side of things. A lot of the SageMaker services, etc., can run serverless, and S3 is usually the main source of data for machine learning. Generally, when people are bringing data into the machine learning side of things, it will be stored in S3 usually as a data lake, where all of your information, your data is stored there in either a structured or unstructured manner. So it can have just raw data that you still need to process, or data that you've already processed. And then you can use other functions like triggering on a file being uploaded to S3. You can run things through Kinesis Firehose or Kinesis data analysis to actually analyze the data as it's coming in. And then you can use that as the basis of your machine learning training or your actual model prediction. So you can have a training set of data that you feed into a model and tell it what you want to try and get out of that machine learning process. And then you can use API Gateway or other similar services to actually query the model to do a sort of live lookup to say, okay, what is this based on the training data, and actually query the model. So yeah, there's definitely a lot of areas in machine learning that use serverless, and as I say, S3 is a key component of it.
Yeah, absolutely. I think just remembering one of the cool projects that we did together actually is build a data lake where we ended up storing a lot of images, which then triggered a couple of lambdas. There was glue involved somewhere to do a catalog of things, and you can actually there's actually one of the services, I think there is a lake builder service or something like that in Amazon, which enables data lakes at a very fast pace, almost like within 15-20 minutes you can actually get a data lake up and going. You know, that's isn't that mind-blowing, right? So that's great. You know, the speed of things, that's one of the key advantages I believe in serverless, right? So
yeah,
like, cool.
Speed and automation as well, and having things linked together. So having your infrastructure and serverless set up so that you can have as soon as something comes into S3, you can trigger a chain reaction of different things. So one of the other services that we built was it wasn't fully serverless, but involved some of the serverless side of things, where when a file was uploaded into S3, we would take that data, transform it, and load it into an RDS database based on what was in the file, and also store the original file in a separate database where it was processed. So the end user essentially just needed to upload the file, and then the entire process would happen automatically, and then they would have their data in the database in the format that they wanted, processed in the way that they wanted it to be. So that was really useful and really time saving for them, instead of having to use something like MySQL Workbench where they had a lot of SQL files to import.
Remind me, I thought it'd be worth mentioning, what was the total size of data I think they plan to import with that project? I
think it was some of the files were anywhere between 5 gig and 20 gig per file, and they were uploading probably in the region of about 100 of those files a day. So it was a very large. The end process was a very large database. So the RDS, it would take them ages to actually do that manually. But yeah, we had to process, I think the largest one was 20 gig, if I remember rightly, or in the region of that.
Yeah, and terabytes obviously in total size of data, and all made very efficient because the serverless helped fill the gap.
Yeah, exactly. Yeah, it's really useful. The Lambda especially and S3 and the triggers are really useful for gluing processes together and having that microservices framework and having things talk to each other. Is really useful in doing a lot of the different steps in between.
Yep, that also brings a very interesting point, right? Not all the architectures we build are serverless, right? So it is basically an amazing glue of things. We can easily build hybrid architectures, part serverless. You know, you leverage part of these things as serverless things. Then part of it is actually traditional stuff. So when we think about lift and shift into the cloud, and then we look at re-architecting stuff, it doesn't ever needs to be a big bang. You can start, you know, chipping it away on small things. So breaking up a big monolith into microservices is essentially what it ends up being. So half of it will be microservices for some time, half of it will still be monolith. You're basically removing things away from the monolithic architecture, creating this nice little hybrid thing towards its destination of goal of being pure cloud native and being pure serverless. So yeah, we are that's amazing, isn't it? So but we are near our 8 o'clock mark in any case. I think we haven't yet had any more questions, have we?
No, I can see no.
Cool.
No, you must have answered everyone as you went along. So
Yeah.
So great on that front. So I think we've given people long enough if they want to ask a question. So if you can just move the slides on, Mahal, thank you. We'll just cover the remaining points.
Yeah.
As mentioned, the presentation will list on the user group website on meetup.com, and we'll send out a link in the presentation to a survey that helps us get better feedback on what you'd like to hear from us in terms of user groups. So it'll be tomorrow. I expect it'll be posted, but it'll be posted on the Meetup website. And as mentioned a couple of times, if you fancy a bit more of a deep dive, in Cirrus running an event in conjunction with AWS, where they'll even sort out temporary Amazon accounts for you, so you can mess about with this kind of stuff without fear of breaking anything in your own accounts or running up a giant bill by creating a recursive Lambda. So that is on the 21st of April from 1:30 to 5:30 in the afternoon. So we'll post further details on the Meetup group on how you can register for that. So it's no cost to you, and it's just available. There is a limited number of spaces, so if that is interesting to you, once the details are posted, please register, because once it's full, we might not be able to get anyone else in. And that's it. So thank you very much. As you've seen, this is the second virtual one we've done since lockdown started. We anticipate doing more virtual user groups before we're all back in the same room together, unfortunately. But we'll keep an eye on the Meetup group for more details, and we will post the next Meetup group there. So just a couple of bits of feedback, no questions, but a couple of bits of feedback saying how useful it was. So thank you very much, Kirsten and Lucas. That's much appreciated for your feedback there. So thank you very much for everyone for joining us. Thank you to Mahel and John for contributing through the talks and the questions, and a few other thanks to go to. There's a lot of people involved to put one of these events on together. So my thanks to Nick, Lauren, Damon, Pete, and Alistair, who all have also been involved in various ways in organising tonight's event. So thank you very much, and we'll see you all here at the next user group.
Cheers, guys. Thanks. Bye.
Thanks, everyone.
Bye.
Bye.